Okay, let's look at page 288, problem G2. In this problem, we want to show that these two sentences are provably equivalent. That would mean, from the first one, which I'm going to write here for my convenience, for all x not ax implies b of d. From that sentence, you can prove the second one, which is for all x ax or b of d. Now, be very careful in understanding this, because the scope of that for all there only applies to that left half of that disjunction. You don't have a for all x over everything, and that's going to change how you prove this. Okay, so so to show these are provably equivalent, we want to show that the left proves the right, and we want to show that the right proves the left. So let's start with proving the left proves the right. Remember, that symbol means, things with this assumption. I can write a proof that leads to, this assumption. Okay, so let's start a proof, and I'm going to assume for all x not ax implies b of d. Now, the first thing I'm going to want to do is I'm going to want to get rid of that for all, that main logical operator there. And the way I'm going to do it is I'm going to I'm going to have to replace x with something. Now, it's tempting to maybe use d for x. The problem is eventually I'm going to want a for all over this variable I'm replacing, right? I mean, looking at this, I'm going to have to introduce a for all to whatever this a becomes, and that's a problem. So I don't want to pick d. I'm not allowed to universally quantify over a d, because according to the rule of universal introduction, I can't universally quantify over a named constant appearing in an undischarged assumption. And that d in this assumption can never be discharged, because it's a base assumption of the whole proof. So we're stuck with the d, and we don't want to introduce another one. So in this case, I'm going to write something like not a of c implies b of d. Okay. Now that at least will avoid this problem that I have with not wanting a d in there, another d. Okay, now if you look at the rules that we have to work with, and my computer crashed, so I have to find them again. 1 second, there we go. If you look at the rules we have to work with, only some of them even seem applicable, right? If I'm gonna, what I want to do is I want to get either for all x ax or b of d to sort of appear down here. Then I can OR the other one on. Now, one way that you might think to do this is to try maybe these negation rules. I've looked at them, and I don't really see how you could use them, because these contradictions are in here, and I don't know how you're going to get the contradiction. We only have an implication here, and that's pretty difficult to get a contradiction out of. So these rules kind of are not useful. Now the conjunction rule, also not very useful. Explosion, no. Conditional, not really. Now, yeah, I mean, of course, conditional is useful. I mean, we may use conditional elimination because we have one here, but we're not going to be creating a conditional. We don't want one in the end, so why would we even look there? Disjunction rules, of course, are important. Going left to right, we don't have a disjunction to work with. Of course, we'll want to use these rules to OR what we want on as much as possible, because we want to end up with an OR in the end. So biconditional, not so useful. So not many of these seem like they're applicable. Modus tollens has some potential, but I wasn't really able to see how to do it with modus tollens. The problem is I would need somehow to have not b of d here. And if I could get not B of D, then from modus tollens I could get not A of C. From that I could get, using double negation, A of C, and then I could universally quantify, and then I'm done. So that's certainly an option, but I'd have to end up with not B of D at this level first. Now, maybe I could accomplish that using, negation or something, but I know a faster way. Okay. Now, what I want to use is exclude middle. The question is, what should I use as my A? Now, it's very tempting to pick, and let me pick a piece of scrap paper for this. If I picked, let me move this. Just want to show you why this won't work. If I picked A of C as my assumption, then, in order to get what I'm aiming for, this thing, I don't want to OR anything onto that, because, well, that's a problem. I only would want to universally quantify at this point, so I'd want to write this. But that's not allowed, because the rules for universal introduction say that the name constant you're replacing cannot appear as part of an undischarged assumption. That's an assumption, and you're certainly not discharged when you're in the middle of the proof of it. So that won't work. We cannot use A of C as the assumption. So what we're sort of left with is having to use B of D as the assumption. And that's going to work. So first thing I'm going to assume is B of D. From this, I have this, and I have an OR between them. I can immediately jump to what I want. No questions asked. I can just put whatever I want there. That's OR introduction on line 3. So that was the easy one. In order to use law of excluded middle, I also need to assume the negation of the same thing. I have to assume the negation of B of D. So that's line 4. This is line 5. So now what am I going to do with that? Well, I have an implication, and I have now assumed the negation of that implication. Well, we were sort of talking about that earlier. That's a modus tollens situation. And so what I'm able to conclude from that is not of the script A. Now, script A in this case is the not of A of C. So I'm going to get not A of C, right? I get a negation in front of whatever's on the left side there. So I get not A of C. And that's modus tollens. And how do I cite it? I cite the implication first, and then I cite the negated thing second. So I cite first 2, and then I cite 5. Well, that's not quite what I want, but it's closer. So now I can use double negation elimination, and I can get rid of that double negation, no problem. So now I can get A of C. Now, that's very nice, because now the A of C is here, but it is not part of an undischarged assumption. D is, but D already was, so who cares? C is not part of an undischarged assumption. It's, all C's are consequences. So this is line 6, this is line 7. So what that means is I'm now not forbidden. In other words, I'm allowed to universally quantify over that C. So I get A of X there. So that's this. That's for all introduction on line 7. And now that I have the left-hand side of that disjunction, now I can just OR on the right-hand side willy-nilly. So I'll get for all X, AX, or B of D. And that's or introduction on line 8. And then finally line 10, because I have an assumption with the conclusion I want, and then the negation of that assumption with the same conclusion, I can use law of excluded middle to say, well, that conclusion must be true. So I'm allowed to conclude for all X, AX, or BD. And that's law of excluded middle, and I just have to cite the non-negated subproof first, so 3 to 4, and then the subproof where I assume the negation 5 through 9. And that concludes the proof from left to right. Now let's try the other one. Let's try to go right to left. Now, fundamentally, in this proof, the main logical operator is the OR. Okay, it's not the quantifier. So I'm forbidden at this point from, I'm forbidden entirely from, removing that for all off of there. So what on earth am I going to do? Well, if we look at our rules for disjunction, if I start with a disjunction, I want to assume A, the one of the halves, arrive at the conclusion I want, and then assume B and arrive at the conclusion I want. So, the first thing I would do is I would assume for all x, AX. Okay, so for all x, so this is assumption of a subproof, for all x, AX. Now, I have to do it that way. I cannot remove the for all until the for all is the main logical operator. Okay, so now I am free to remove the for all, and sort of in line with before, I will do that, and I'll get A of C. Now, what I want to arrive at is not A of C implies B of D. Now, the problem is that I don't have a not A of C, and if I concluded this subproof was something, I wouldn't end up with an implication of like not A of C implies B of D. I would end up with for all x, AX implies something. So if you think about what I'm, my current sub goal here, can you see that? Yeah. My current sub goal would be to get not A of C implies B of D, if I could manage that. If I can do that, then I can universally quantify, because C was not part of the assumption of an undischarged assumption. Well, to get an implies, that's easy, right? Any implies can follow from assuming the left side of that implies. So that's my line 4. It's an assumption. I guess I should justify this line, huh? For all elimination on line 2. Now, it seems absurd to assume not A of C, but, and it is. I get a contradiction immediately. Let's look at how that's cited. So, that's this rule here. Negation, elimination, and I first cite the negated thing. So then I cite 4 and 3. But the power here is that I'm now allowed to write anything I want by explosion. So I'm going to write B of D now. And that's explosion. And when I cite explosion rule, I just cite the contradiction that came before. So that's explosion on 5. So what I have here is a subproof starting on line 4, ending on line 6, with this initial assumption and this end assumption. So, so I end up with A of C implies B of D. And so that is implies introduction on the subproof from 4 to 6. That's line 7. And now, thinking about where I want to go, I want to get the left side. Oh, sorry, that's negation of A of C. Let me put that in blue so it's clear. Negation of A of C, my bad. Can you see that? It looks like it. Maybe this needs to be a little bigger. Negation of A of C implies B of D. And because the C here is not part of an undischarged assumption, then I'm welcome to universally quantify over it, and I get this. Not A of X implies B of D. And that's for all introduction on line 7. Now that concludes that subproof, okay? Because if you think about where I'm going with this, that's this part of it right here. That's this first subproof. Now I need to assume B of D and somehow arrive at the same thing. This might be more complicated. Maybe not. Actually, maybe not. I mean, if we think about the structure, it might not be. So let's go ahead and make a new assumption. I'm going to have to go to a new sheet of paper. Assume now the right half of this, B of D, and I'm going to want to arrive at this formula here. I'm going to arrive at this formula here at the end, or this formula in the end. Now I have to be careful because I can't let's see. I have A of C. No, I don't. I'm going to figure this out and then concatenate it to this right to left part. I'm not sure what to do. So I'm going to stop the video here. I'm going to figure out what to do, and then I'm going to record how I'm going to do it. I might, my recording might start at line 9. I'm not quite sure yet. So it should come now. Okay, so I know what to do. So here's line 9, not B of D, and I want to inside here I want to make a subproof where I assume not A of C. Now I can conclude from there B of D, no problem, because that's repetition of line 9. So moving forward, I'll move my my proof over and start writing on a new sheet of paper. Moving forward from this, let me move some bottles that are on my desk. Moving forward from this, I'm now going to start. Let me set my structure up here. Let me copy line 11 just so that there's some continuity here. So line 11 is 3 deep. Let me copy 10 and 11. So here's 10, here's 11. 10 was this third level assumption, not A of C. And then here's B of D. And that was repetition on line 9. Okay, so here we are. So now I can say not A of C implies B of D. And that's implies introduction on the subproof from lines 10 to 11. Okay, so that's great because now I have a C in here, and that C is not part of an undischarged assumption. I mean, it's part of an assumption, it's part of this assumption, but that subproof has been, that assumption's been discharged, it's gone. So that C is now part of an undischarged assumption. So I'm allowed to universally quantify over the C. So I can say not AX implies B of D. That's for all introduction on line 12. And that's wonderful, because now if you look at the disjunction rules, I have started with a disjunction of two things as my base assumption on line 1. I took the first of the two things in my disjunction, and I was able to, by the end, get this statement that matches this. Then I took the second assumption of a second part of my disjunction, and I assumed it, and then I was able to get again at the same conclusion. So by or elimination, I'm able to say, well, that must mean that for all x, not AX implies B of D. That must be true. Okay, so that's for all elimination, and I have to cite the or that it came from, which is line 1, and then I have to cite the subproof that starts with the left assumption, so the subproof from 2 to 8. And then I have the subproof from 9 to 13. Now, this completes the problem, because now I've shown that assuming the, let's see, let me pull this over. Assuming the left gave me the right, okay, that was this proof. The left gave me the right, and then the right gave me the left. So I have satisfied the requirements to prove the formulas in both directions. So these formulas are provably equivalent.